Hey, welcome everybody in this new video. In the last video I showed you local and global variables and how we can use them and how we can program them. In this video I will show you how we use local variables to multitask or multi-thread in LabVIEW. And it's fairly easy, but we need local variables to do it. Right, so let me just open up a blank VI and I'll just give you an example. Alright, so multitasking is really easy in LabVIEW. Let me just create a loop here. Alright, and what we're going to do in this loop is we're only going to, 100, that's enough, and a stop button. Alright, and let me copy this. Alright, so if I have two stop buttons and two indicators, and if I run my loop right now, both loops will run at the same time. And you can see that both numbers are actually increasing. I can stop the first loop and the other one is still going on. Alright, so that's the first thing I want to show you about multitasking. And LabVIEW automatically doesn't matter how many loops you have. It executes as much loops at the same time as possible. So it does. If you have, I'm not sure how far we can go with this actually, but right now we have 4 loops, and I know 4 loops. They can all run at the same time at least. So LabVIEW automatically distributes all the calculations over the available processors. You can actually change settings somewhere where you can disable this. Maybe you can say, alright, I only want to use one processor for LabVIEW, for example. That's a possibility, but it automatically uses as many as possible. Right. Now we run into a problem when we want to exchange information between loops. Alright, let me show you that by I want to know the difference between the two loops. Let's change this to 150. Alright, so I want to know how many loops did bottom do. What's the difference between the bottom indexing and the top loop indexing? So how many loops is the bottom loop lagging behind from the top loop? I could do that by just simply I can do that by simply subtract. I can simply do that by subtracting this numeric indicator from this numeric indicator, and then I get with an indicator I can get a difference. Right, so this should be the difference. And there's only one problem, because if I run my loop right now, I can show you with highlight execution. We have a data flow problem, because this loop tunnel will only output information here and once I break out of the loop. And same for this loop tunnel in the second loop. The second loop will only start running once all the inputs are available. That's what we learned with data flow programming. So that means that this loop is going to wait just as long until there's information ready at this tunnel, at this input, before it can actually start running this calculation. So if I press stop, then we break out of this stop loop and we can start the second loop. And now it will always be subtracting with 25, because that's where I broke up the first loop. Alright, so that's a problem, and we can solve this problem with local variables. Right now I'm trying to wire this up, but we need to just do it wirelessly. And I can just insert a local variable in here. And what I need to do is I need to read out this value. And I can do that by just selecting this. Selecting the value that I want to read out. In this case numeric, because as you can see it's called numeric. And I need to change it to read, because I need to read it out. And if I run it right now, then you can see that both loops are actually running at the same time. So they're both executing their loops. It looks a little bit weird, but This loop is running as well. You can see it because this indicator is increasing in value. Alright, so that's how we exchange information. And we used to exchange this information, for example, if we're doing a measurement and we're having one loop which is doing the measurement, another loop is doing the analytics. So if somewhere it skips a beat, or there's a bug in the program, or it misses an iteration, for example, then not my entire program is runs into an error, but only that small sub process. And we can do the same thing, by the way, now for the stop buttons. We're having two stop buttons, and I would like to have one stop button to stop all the loops at once. And so I just want to use this stop button. Do exactly the same thing. I go to my local variable. I change it to read because I need to read out, and I'm just going to read out this stop button. And then I wire that same state. So this button, whatever the status of this button, is been read out by this local variable function. So if I run, okay, I run into an error. Let's see what it is. Boolean action is incompatible. Local variables. Alright, so we're running into a problem that my latch action is incompatible with my local variables. Okay. Alright, so we haven't been talking about this, but these buttons and all these switches that we use in the front panel, they all have a mechanical action. That means does the switch react when we press it down, or does the switch react when we release it? So as long as we keep it pressed, there's nothing going on, and once we release it, then everything is changed. Right now it's in latching, and so how can we change that mechanical action? By just right clicking on the button, and then here we have mechanical action. And we have to use, so we can use latching, that's one option, but we also have switching, and apparently latching won't work, or I reckon that, no, this won't work as well. Alright, so latching won't work. We need to have the other one, which is switching. And in this case, I think I want to use this switch when released. Yeah, now it works. So if we run it right now, you can see both loops are running. And if I press stop, then both loops are stopped. Alright, so far this multitasking operation. In the next assignment, you guys will need this operation. So use local variables and multitask as well. Alright, good luck guys. See you in the next video.